Hello dear subscribers of this channel, welcome. In this video we take a look at the Springer Handbook of Global Navigation Satellite Systems, a comprehensive reference that covers the foundations, technologies and applications of GNSS worldwide.
Book, Springer Handbook of Global Navigation Satellite Systems.
Okay, let's start. In this book we have two editors, and the first is a Theonissen and the second is a Montenbrook. Okay, and we have many authors. Okay, and many important authors for this book, but I want to cite a special author is Felix Antrich, and teacher at Federal University of Ceará, UFC, Department of Teleinformática Engineering, okay, in Fortaleza, Brazil. And in this moment, Felix is a teacher of ITA, or Instituto Tecnológico de Aeronáutica, localization in São Paulo or São José dos Campos in Brazil, okay? And this is a teacher for signal process of GNSS. And can you see we have many important authors, but we have a more less time. Time is short, okay? In content, we have a list of abbreviations. And part A, Principles of GNSS. Number 1, Introductions to GNSS. Okay, for Richard, Peter, and Oliver. Early satellite navigations, concept of GNSS positioning, modeling to observations, position modes, current and developing GNSS for science and society at large in reference. And 2, time and reference systems for Christopher and Oliver. And we have time, spatial reference systems, terrestrial reference systems, celestial reference systems, transformations between ICRF and ITRF, and perspectives. Okay. And 3, satellite orbit and altitude, or Urs and Oliver. And we have a Klepian motion, orbital perturbations, broadcast orbital models, and altitude. And 4, signals and modulations, Michael, and this case, Felix Antrich. And we have radio frequency signals, spring spectral technique and pseudo-random codes, modulation schemes, signal multiplexes, and navigation data and data-free channels. Okay, and we have clocks for Ron and Ken, frequency and time stability, clock technologies, space qualified atomic standards, relativistic effects on clocks, international timescales, GNSS timescales. And 6, we have atmospheric signal propagations for Thomas and Norbert, electromagnetic wave propagations, troposphere, ionospheric effects of GNSS signal propagations, and part B, satellite navigation systems, and number 7, the global positional systems, a GPS, for Christoph. Okay, we have a space segment, control segment, navigation signals, navigation data and algorithms, time systems in Geodesy, services and performance. Okay. And number 8, GLONASS for from Sergey, Alexei, Alexander, Oliver. Overview, navigation signals and services, satellites, launch vehicles, ground segment, GLONASS open service performance. And number 9, Galileo from Marco, Charg, and Thomas. Constellation, signals and service, spacecraft, ground segment, and summary. Okay. 10. Chinese navigation satellite systems for Yangshi, Jing, and Oliver. BeiDou Navigation Satellite Demonstration Systems, BDS-1. BeiDou Regional Navigation Satellite System, BDS-2. Performance of BDS-2. BeiDou Global Navigation Satellite Systems. Brief introductions of CAPS. Okay. 11. Regional Systems from Satoshi, AES Ganeshan, and Oliver. Concept of regional navigation satellite systems, quasi-zenith satellite systems, Indian regional navigation satellite systems, EIRNSS or Navy, and 12 satellite-based augmentation systems from Tori, aircraft guidance, GPS error sources, SBAS architecture, SBAS integrity, SBAS user algorithms, operational and planned SBAS systems, evolutions of SBAS. Part C, GNSS receivers and antennas. And 30, receiver architecture from Bernd and Chong. Background and history, receiver building blocks, multi-frequency and multi-system receivers, technology trends, receiver types, and references. Okay. 40. And signal processing, Chung and Thomas. Overview and scope, receiving signal model, signal search and acquisitions, signal tracking, time synchronizations and data modulations, GNSS measurements, advanced topics. Okay, and 5T and multipath. Okay, we have Michael, the impact of multipath, characterizing the multipath environment, multipath signal models, pseudo-range and carrier phase error, multipath errors envelopes, temporal error, variations, bias, characteristic, and fast fading considerations, multipath mitigations, multipath measurements, and note about multipath impact on Doppler measurements, and conclusion. Okay, 16 interference from 30 analysis techniques for statistically independent interference, canonical interference models, quantization effects, specific interference waveform and source, spoofing, interference detections, interference mitigations. Okay, 17 antennas from Moser, Steven, and Oliver. GNSS antenna characteristics, basic GNSS antenna types, and application-specific GNSS antennas, multipath mitigations, antennas from GNSS satellites, antennas measurement and calibrations. 18. Simulators and test equipment, Mark, James. Background, RF level simulators, IF level simulators, record and playback systems, measurement level simulators, combining live and simulated data, and other considerations. Part D. GNSS algorithms and models. 90. Basic observations equations from André. Observations equations, relativistic effects, atmospheric signal delays, carrier phase wind up, antenna phase center offset and variations, signal biases, receive nodes in multipath, and 20. Combinations of observations from André. Fundamental equations, combination of single satellite and single receiver observations, combinations of multi-satellite and multi-receivers observations, pseudo-range filtering, okay? Positions, 21. Positioning model from Dennis. Nonlinear observations equations, linearization of the observations equations, point positions models, relative positions models, differential positions models, the positioning concepts related, and 22 least square estimations and common theory from Sandra and Peter. Linear least squares estimations, optimal estimations, special forms of least squares, prediction and filtering, common filtering. 23. Carrier phase integral ambiguity resolution from Peter. GNSS ambiguity resolutions, rounded and bootstrapping, linear combinations, integral least squares, partial ambiguity resolutions, when to accept the integral solutions. 24. BET and recursive model validations from Peter. Modeling and validations, batch model validations, testing for a bias, testing procedure, recursive model validations, and references. And Party A, positions and navigations. 25. Precise point positions from Chen, François, Pierre. PPP concept or triple P significant precise positions corrected models. Oh, excuse me. Specific processing aspect, implementations, examples, and discussion. 26. Different positioning from Dennis and Lambert. Different GNSS concepts, different navigation services, real-time kinematic positionings, network RTK, and references. 27. Altitude determinations from Gabriel. 6 degrees of freedom, attitude parameterization, attitude estimations from baseline observations, the GNSS attitude model, applications, an overview of GNSS, ENS sensor fusion for attitude determinations, okay? 28. GNSS INS integration from J and Dan. State estimation objectives, inertial navigations, inertial sensors, strap-down inertial navigations, analysis of error effects, IDET navigations, state estimations, TNSS and IDET INS, detailed example, alternative estimation methods, looking forward, and references to. Okay, 29. Land and maritime applications from Allison and Terry. Land-based application of GNSS, rail applications, maritime applications, outlook, and references to. 20. Aviation's applications from Richard. Overview, standardizing GNSS for aviations, evolutions of the flight deck, from the RNP concept to PBN, GNSS performance requirements, linking the PBN requirements and the GNSS requirements, flight planning and NOTAMs or NOTAMs, regulation and certifications, military aviation applications, other aviation applications of GNSS, and future evolutions. 31. Ground-based augmentation systems from SEM. Components and overview of local area approaches. Ground-based augmented systems augmented via ranging signals, pseudo-lights, and outlook. Okay. 32. Space applications from Oliver. Flying high, spacecraft navigations, formations flying and rendezvous, other applications, and refers to Part F. Surveying, Geodesy, and Geodynamics. 33. The International GNSS Service from Gary, Anna, and Grant. Mission and organizations, components, IGS productions, pilot projects and experiments, and outlook. Okay, 34. Orbit and clock productions generation from Jen, Peter, and Tim. Global tracking network models, POD process estimation strategies, software products, and outlook. 35. Surveying from Chris. Precise positions techniques, geodetics and land surveying, engineering surveying, hydrographic surveying, and reference to 36. Geodesy from Zuher and Richard. GNSS and IIG's Global Geodetic Observation System, global and regional reference frames, and Earth rotations, polar motions, and notations is very important. And 37. Geodynamics from Jeff. GNSS for geodynamics, history and establishment of GNSS network for geodynamics, rigid plate motions, plate boundary deformations and earthquake cycle, seismology, volcano deformation, surface length deformations, the multi-GNSS filter, and Part-T GNSS remote sensors and timing. 38. Monitoring of the neutral atmosphere from Gunnar and Jens. Ground-based monitoring of the neutral atmosphere, GNSS radio occultation measurements, and outlook. 39. Ionosphere monitoring from Norbit. Ground-based GNSS monitoring, space-based GNSS monitoring, GNSS-based 3D tomography, scintillation monitoring, space water, coupling with lower geospheres, information data services, and reference to 40. Reflectometry from Antonio and Estelle. With series models, applications, spaceborne missions, and references. 41. GNSS time and frequency transfer from Pascal. GNSS time and frequency disseminations, remote clock comparisons, hardware and architecture and calibration, multi-GNSS time transfer, and conclusions. Okay, in this topic we have Annex A data formats, Annex B GNSS parameters, about the authors, detailed content, glossary of defined terms, and subject indexes. And this video is more large because handbook are um, a big book, okay? In this context, we have many topics for study, and thank you for your attentions. Please, if you could subscribe and like or comment for this video, and thank you and see you.